For section 3.5, exponential and logarithmic models, we have one example to get you started on your application problems. So let's start with a Dell computer that cost $1,150, has a book value of $550 after 2 years. And we're going to look at two different models and compare the cost of the computer after so many years. So we're going to start off with a linear model, and this is something that you're familiar with. V equals mt plus b. This looks similar, or this should look similar to, or familiar to you, y equals mx plus b, like your slope-intercept form. So we need to figure out maybe what the rate of change was, or think about like what the slope was. How much did the computer depreciate each year? Well, it started at $1,150, $1,150, and it was worth $550 after 2 years. So it depreciated $600. Divide that by 2 years. So it dropped about $300 per year. So your slope, your rate of change, was a negative $300. So the value would be negative, pen's going nuts again here, negative $300 times t, which would be the number of years, which is where your x normally is, plus b, which is your y-intercept, which would be your starting value, $1,150. Write the linear model. That should have been a piece of cake for everybody. So you would start at 1150 on the graph, go down 300 over 1 when it comes time to graph it. So there's a linear model. That one was easy. Now let's try something a little more complicated. Now let's try the exponential model. Same computer, same information, now the exponential model. This is where it gets a little more difficult. We can plug in the A, which is the starting amount. We can plug in, t for time. We can plug in just about everything. But this k right here, we don't know. We have to calculate the k first, because k is like our rate. It's the rate at which the computer is decreasing in value. So we have to calculate the k. So let's figure out what we can plug in to calculate the k. We have a starting value, and we have an ending value, and we have a time frame. So let's plug that in where it goes and see what we can come up with. We have an ending value of $550. We have a starting value of $1,150. E is always E. We don't know what k is because that's what we're trying to solve for. And we know that out of these two values, the time frame was 2 years. So I can plug in a 2 right there. Now, this was similar to the example we did in the last lesson about how long does it take your money to double. So we're going to go through the solving process here. We're going to divide this by 1150. So we're going to divide both sides by 1150. That does not divide out nice and neat, and no, you're not going to give me a decimal. You will reduce this fraction and you will leave it in a fraction form. So this is going to be 11/23 equals e to the 2k. And I'm going to flip this around. Some of you will be able to do it fine without me flipping it around, but I'm going to flip it around. Oh, that's 23. Now let's take this out of exponents and let's turn it into logs. Left, right, left. Log base e of 11/23 equals 2k. Log base e means natural logs of 11/23 equals 2k. How do I get the k by itself? Divide by 2. So natural log 11/23 divided by 2 will give me the k. Now this that we're just doing right here to find the k, get used to it. You're going to do a whole day's worth of practice solving for k. It wasn't that difficult, but you're going to have to do a lot of practice solving for k. So natural log of 11 over 23 divided by 2 equals k. For now, for this problem, we are going to estimate k. Alright, to estimate it, we're going to use 4 decimal places. This is negative 0.3688. So for my k right here, it's negative 0.3688. So my exponential model will be my starting value times e to the k value times t. There's your exponential model, but you had to go through the process of finding k. The next part says to use a graphing utility, which is your calculator, to graph the two models in the same viewing window. I don't know how many of you have a calculator with you when you are looking at the graph, but I'm going to give you a window here. Your Y max, you're going to need to go up to 1200 on your Y max. Your X max over here, you're going to need to go out to about 6, maybe 5 years. I mean, think about the life of a computer. You know, life of a computer, you wouldn't go out to 20 years or even 10 years maybe. I don't know, some of you may keep a computer that long, but the life of a computer, 4, 5, 6 years. I went about 6 years on my life of my computer. And if the price was $11.50, then going up on the Y max, the price $1,200, that's a reasonable window. So I have the graph on here already for you. There's the graphs. There's your graphing utilities. They both started up here at $11.50 and they both come down. Hopefully it's not too hard to figure out which is the linear and which was the exponential. Obviously the linear is the straight one and exponential is the curved one. Which model depreciates faster in the first 2 years? Well, here's year 1, here's year 2. Which one depreciates, which one drops off faster? The exponential dips down quicker in the first 2 years. So that would be exponential. After that, it kind of levels off a little bit, and then the linear would drop off quicker. But the exponential drops off quicker in the first 2 years. Right, the last thing we want to know about this computer is we want to figure out, using the equations we came up with, we want to find the book values of the computer after 1 year and after 3 years using each model. So using the linear and the exponential model, what's that computer going to be worth after 1 year, and what's the computer going to be worth after 3 years? So I have my equations in my calculator, and I'm just going to look at the table to get that information. So after 1 year, the linear model is worth $8.50, and the exponential is worth $795.30. And after 3 years, the linear is worth $2.50, and the exponential is worth $380.36. So I'll come back over here and write those answers down. On the linear, after 1 year, $8.50. The exponential was worth $795.30. We said the exponential dropped off quicker, and you can see that it did. And then the linear, after 3 years, it was only worth $2.50, and after 3 years, the exponential held its value a little bit better. What was that? 36 cents. Okay, so now you should be able to do some of those on your own.